Good afternoon. All right, so everyone doing okay today?
Yeah, we good.
Anything exciting going on?
It's pouring right now outside.
And
It looks like a pretty wicked storm here in Holbrook. So you've already got the rain. How about in anywhere else? Is it raining?
Yes.
In St. John's?
Here.
Yes, it rained a ton.
It rained a ton? Well, that's good. How about in Hopi?
What was that question? Was it raining?
Yeah, is it rained this afternoon?
No.
No?
It's a desert.
How about Alchese? Or White Mountain campus? In Sholo, is it raining?
No, but it's been very cloudy, so hopefully it will rain. We'll see.
All right. How about Winslow?
Yeah, it's raining.
Okay. So here's the deal. When it rains really hard, it seems like the odds are we lose one of the. Let's see, can you see me? Oh, there I am. Okay. It seems like we lose somebody. So hopefully it's not you. Actually, if it's me, then we lose everybody. But anyway. So I don't know. It's just the nature of the beast. But so St. John's, we have problems with your internet, and I got another follow-up email that anyway that I guess some of the tech guys resolved some of the issues. So hopefully we won't have to worry about that. But I will say that of all the internet, probably the different schools, St. John's and Mogollon kind of goes out the most. So I don't know what that means. Maybe you guys get the most snow or something. I don't know. But anyway, so in St. John's, you guys does your internet go out a lot at your own house? Your personal internet?
Yeah.
So maybe you've just got a crappy carrier or something. I don't know.
We only have one carrier.
Oh, what is it?
Frontier.
Oh, Frontier.
Yeah.
And isn't that who you guys have in Mogollon?
Yeah.
Yeah, it's the
Yeah.
worst.
See, I'm sensing a pattern here. I don't know. I don't know. I shouldn't say, but I just anyway. Joey, where you sent me an email, that was helpful to because I could follow up with both you and the Talon guys. But I did call them in here, and then I emailed them once class was over. But I will be posting the video, so if you guys, just kind of forward to the part that you missed, or maybe you can figure stuff out. I don't know.
Okay.
Whatever works. But you don't, anyway. But do let me know and so when usually the Talon aides, they'll call in and they'll usually get right on it. They're trying to do a new reporting system to me. So if you've already reported an outage, they don't want me to have to stop class, and so they'll send a message to me through the board number 2. And I kept looking for that, and I didn't see it. But anyway, we're still kind of working all that out. But it'll all be good once we get it figured out. So okay, now well, let me take roll, and then I'll keep talking. Joran.
Here.
Rachel.
Here.
Alana.
Here.
Okay, Nathan.
Yes.
Not here.
All right. David.
Here.
Did I say that right this time?
Yeah.
All right. I'll get it down. Chloe.
Here.
Aiden.
Here.
Junior.
Here.
Rhett.
Here.
Oh, I remember in Winslow, didn't we say that Alana might have dropped?
Yeah, she's here though.
Oh, she's here? But she dropped?
No, she's here to take the class.
Oh, okay. So, okay.
No, not Brooke.
Taylor.
Okay. I
Taylor.
totally misunderstood.
Taylor was the one that dropped.
Okay. So, yeah, I've got Taylor. Normally, we just have to, I try to follow up and make sure that they actually get removed officially because we don't want any problems with, transcripts or something like that. So, anyway, we're good. Let's see. Did I say Rhett already? I think Price.
Here.
Alan.
Here.
Denon.
Here.
Timmy.
He dropped it?
I think
I
he's
think-
dropping the class.
Okay.
I think he's in the counselor's office right now.
Okay. All right. Well, doesn't he have to get his dad's signature?
Probably.
Right. Okay, Matthew.
He dropped the class.
Okay, I thought so. All right, Skylar.
Here.
Hannah Whipple.
Here.
Here.
Brooke.
She dropped it too.
Okay. All right, so we have to make sure on those that, and I'll do what I can from my end, but they need to make sure that they officially drop through with Miss Heaster. Joseph
Here.
and Hannah Zent.
Here.
Okay. Okay, let's see. Let's see. Okay. All right. Let's see. What else was I going to talk about? Oh, so I'll see you tomorrow, but just to let you know that Monday is a very rare occurrence, and that is that MPC actually has a holiday. So there is no class at all on Monday. So, and I think all the schools are closed. So we actually have a true holiday. So that'll be nice. So
Hey,
don't-
Mr. Strom.
Yes.
Can I change my schedule for the quiz taking things real quick? I just need to go from 10:15 to 11:15, not 10 to 11.
Okay, let me just. Okay, so this is Hannah. And how about Jorn? You still want 10 or do you want 10, 15
Here.
too?
I can do it with Hannah. If it makes it easier on you, I don't care.
No, I don't want you to do it with Hannah. Maybe at the same time as Hannah, but not with Hannah.
Get her.
I know, but if it makes things easier on you, I don't care what time I
Oh.
take it as long as it's between 10 and 11:15.
Okay, so let's make it 10:15. I've already got it set up. Oh, did you take it today?
Yes, I did.
Yeah.
I took
took-
my test today.
Okay, so you took the little syllabus thing. So you guys are the only ones that have taken it, right?
Oh. No, we took it.
Oh yeah, you took it. Okay.
Yeah.
All right. So any issues to report?
No, it's all good.
You tricked
All right. All right. So I told you that really was almost like a gift of points, and but it's good. I'm glad. Okay. So what am I doing here? Okay. Let's change that and Okay. So, we're just going to finish up 1.1 today, and then we'll go in on 1.2. Now, excuse me. So the way it works, where we'll finish 1.1 today, and then so whatever sections that we finish during the week, like by say Tuesday or whatever, then that will be next week's quiz. So as we finish 1.1, then I'll put that on the list to upload that quiz for next week. Okay. So typically you'll have at least one quiz. Okay. And price. I got an email from I already set you up on the time that we agreed, and your librarian was, like you said, was concerned that she's not a teacher or whatever. It's no problem. She'll be fine.
I told her that.
Yeah. It's no big deal. So I'm going to email her back, and but just plan on taking it in there, and then just let me know if there's a problem.
Okay. Thank you.
All right. So, any other questions about anything before we get started? All right, you guys want to hear a joke?
Yes.
Yeah.
Okay, so just to give you a little background, I had a good friend of mine, turned 50 today. Okay? So her husband calls me up and asks me if I would MC a party for her. And because I've done that, and where I just kind of arrange a party and set it up and whatever. So I said, do you have a theme? And he says, no. And so I said, now, so you're going to let me do whatever I want? And he said, sure. And so what I did is I threw her a party, and I had it set up like a funeral home, and had everybody wear black. And we brought like funeral potatoes and funeral salad and everything like a funeral. And I played like funeral music and stuff in the background. It was so funny. She loved it. So I said we were celebrating the death of her youth. like, hey, you said I could do it. But it was all good fun, and the friends came. But anyway, so here's the joke that I told, because I told a bunch of jokes, and we did like a eulogy and stuff for her. So the joke is that when I die, I want to go out like Grandpa, in peaceful in my sleep, not yelling and screaming like all the passengers in his vehicle. Okay. All right. Well, I forgot. It's hard to tell jokes to you guys because everything's muted, and I don't know whether you're laughing or not.
That was funny.
All right, that sort of felt a little fake, but that's okay. Thanks. Though. I'll take whatever I can get. So, all right. Okay, let's go back to something that I know I do well. Not telling jokes, but doing math. So, okay, even and odd functions. So that's where we are on the handout. So, even and odd functions. Where is this? Oh, part 8. Okay. So a function is even if for each x in the domain of f, the f of negative x is equal to the f of x. Okay. And then an even function is symmetric about the y-axis. And then a function y of x equals f of x is odd if the f of negative x is the negative f of x. Now I know that looks pretty similar, but here, when you change the like if you say the f of 2 is 7, if you plug in the f of negative 2, it's also 7 up here. Or the f of negative 2 would be negative 7. So it does kind of change it up a little bit. The even function is symmetric about the y-axis. So this is like a mirror image here. And then an odd function is symmetric about the origin. So if you have it graphed on your calculator, the way you check to see if it's odd is you just turn your calculator upside down. And if you have the same graph, you're good. Then it's odd. Okay? All right. All right, so let's look at a couple of examples here. All right, so is this function even or odd, or neither?
Even.
It's even, because it's symmetric about the y-axis, okay? All right, so this is, are the following functions even, odd, or neither, okay? Let's see, do we have the graphs or the, okay, so this one, g of x equals x cubed minus x, and the other one, x squared plus 1. Now, sometimes you can just look at the function, or you might need to graph it in your calculator to determine if it's even or odd. But just see if you can determine. And it's possible it could be neither. So those are the choices, even, odd, or neither. All right, Jordan, what do you think for the first one?
Odd.
Okay, it is odd. And you can do it from the graph, or if you plug in the negative of x and work it out, then what you end up with is the opposite of what you started with. Okay, so that's odd. All right, Rachel, how about the second one?
Even.
Okay, even. And so that one is just a parabola shifted up 1. So that's symmetric through the y-axis, so that's even. Okay, so if it doesn't have that symmetry, then it's going to be neither. All right, any questions on either of those? Okay. Okay, now, again, as part of our pre-calculus review, what we want to do is go through the graphs of common functions, the parent functions, if you will. Okay, so this first one here, what kind of function is this? Just call it out if you know it.
Y is a constant.
Okay, so this is a constant function, okay? F of x equals c. So that's a constant function. All right, what about the next one?
Straight line function?
Okay, it is linear. Both of these are linear, so that would also be a correct answer. But this one, this line that goes at a 45-degree angle, does anybody know what that one's called? Where the points on it would be like 0, 0, 1, 1, 2, 2, 3, 3, like that.
Y equals x.
So y equals x is the equation, or f of x equals x. Y equals x. Anybody know what that one is called? Okay, it's the identity function. The identity function. Okay, how about this one here in red, the third one?
Absolute value?
Absolute value. Okay, good. All right, then down here, this one I call the car hood. Looks like kind of the front end of a car, kind of. But what function is that?
The square root.
Square root, very good. So the square root. Wait, square root, there we go. Okay, and how about the next one?
Say
X squared.
That's y equals x squared, and that graph is a parabola, or you might call it the squaring function. Okay, and then the last one here,
X cubed.
x cubed. So, and you might call that the cubic function. Okay. So the expectation is that you know all of those. And when you see the graph, you're familiar with it. Okay. All right, next. All right, horizontal and vertical shifts, okay? So it says on a calculator graph y equals x squared. So go ahead and put that in to your y equals. Okay, and keep that in for your y1, okay? So now if you go down to the y2, okay, then see what this will do, the +2 on the outside shifts the graph up 2. Okay, now the other ones, what I would like you to do is write down what you think the shift is, and then just put in just the ones that you need to check. But I want you to guess on these other ones, which way it's going to shift, and then put it in the calculator if you need to check your work. All right, so Alana, what does the -3 do?
It goes down 3.
Goes down 3. Okay, oh, I guess I don't have those. Okay, so the -1 inside the parentheses. What does that do? Nathan. Oh, Nathan's not here. David. What does the -1 inside the parentheses do? Let's see. St. John's. Did we lose St. John's again?
No.
Oh, okay.
Wait, who'd you call on?
David.
Oh, David.
Wait, you're asking the one that's right below the up to, right?
Yeah.
He's
No,
asking
no,
the
this one
squared
right
minus
here.
Oh,
So this one, the second one was down 3.
Oh, okay.
So
That
down
should be
3.
that the what is it called? Parabola? Yeah, parabola is shifted over to the right on the x-axis.
That's right. So this one is shifted right 1. Right 1 unit. Okay. Now you might think, well, it's negative. Shouldn't it go to the left? But the horizontal shifts go in the opposite direction as the sign. Okay. All right. Chloe. How about the one with the +2 inside?
Go to the left too.
Yes. So left 2. All right. And Aiden. How about the negative in front?
It's reflected across the x-axis.
Yes. Reflected through the x-axis or across the x-axis. Okay, and then, so Junior, how about tell me all of the shifts in this last one?
It opens down, goes
Okay.
to left 3, and down 1.
Very good, very good. So all you got all 3 of them. So it's reflected through the x-axis or goes down, left 3 and down 1. So you would like grab the vertex and move it into that area. Okay, good. Let's see. Okay. All right, a couple other graphs that you want to know, and I just put these on the paper. There's no really practice problem here, but for exponential functions, if you have exponential growth, this is what the graph looks like. So it goes through the point 0, 1, and it has an asymptote on the negative x-axis, goes through that point, and then goes up. Now, depending on what the base is, the steeper it goes. Now, so that's exponential growth. Exponential decay is when either the base is a fraction less than 1, or if the exponent is negative. Then what you have here is it goes down. And so it goes down and through the point 0, 1, and then it has a horizontal asymptote on the positive x-axis. Okay. All right, and then the last graph here is the log. The log function is it starts with a vertical asymptote along the y-axis. It goes through the point 1, 0, and then goes up. Now, it goes up kind of slowly, but it still is increasing. It doesn't level off. Sometimes on your calculator, it might look like it has a horizontal asymptote, but it doesn't. The log function increases without bound. It goes to infinity. Okay? All right. So, functions and their graphs. Any questions? Okay, so that's it for 1.1. And so we're going to go on to 1.2. Now, even though we're going on to 1.2, don't think that you can't go back and ask me questions from 1.1. So like if you're doing practice problems, and yes, I'll post the quiz on 1.1 next Wednesday. But between now and then, you feel free to ask me questions, okay? And we'll go over extra examples if you want. Do some of those practice problems from the book. Check them. Just make sure that you're in good shape, okay? All right, so 1.2 is on combining functions, shifting and scaling graphs. So we're going to do some more of that with the graphing. But first, we're going to start off with combining functions. So, like numbers, functions can be added, subtracted, multiplied, and divided, except when the denominator equals 0 to produce new functions. So we can do all those manipulations, except you can't ever make the denominator go to 0. All right, so for example, let's say we have two functions. F of x equals the square root of x, and g of x is the square root of 1 minus x. Okay, so then what we do is, let's say if I wanted to add those two functions together, it would just be the square root of x plus the square root of 1 minus x. Those aren't really like terms, so I can't combine them. So that's all I can do, is just write them with a plus in between them, okay? Or if I were going to subtract, I would just do the first one minus the second one, okay? And then if I were going to multiply, the order of subtraction is important. You got to put, so the g function first minus the second one. And then if we're going to multiply them together, I can do that, and since they're both under the radical, I can multiply under the radical, but I can't really take it out of the radical. And then to divide, you just make sure which one's on top. So the f of x divided by the g of x, you put the f of x on top, the g of x is on bottom, and since they're, you can put them under the same radical, that's okay. And then the g divided by the f, you put the g function on top over the x, over the f function, square root of x. Okay? Now, when we combine these, we can, when we want to evaluate the function at a certain number. So let's say we wanted to plug in 5. We could plug in from the beginning and simplify it, or we could wait until we've got our answer here and then plug in the number, okay? So for these same functions on practice 1, I've asked you to plug in 0, okay? So go ahead and plug in 0 and then simplify. All right, so Rhett, you've got the first one. What do you have?
Plus or minus 1.
I think it's just 1. Because you have when you plug in 0 here, you get the square root of 0 is 0. When you plug in 0 here, you just get the square root of 1. So it's just 0 plus 1. So the answer is just 1. Okay. All right. Next, price. How about the second one?
Which one is this one? Is this B?
Yeah, B. F minus G of 0.
I got -1.
Okay. -1 is correct. All right. And Alan, how about C?
I got 1.
1 is correct. Good. And Denon, what about the next one, D?
Zero.
Okay. Yep, so you get yeah, so you get 0. Here, let's little line that's okay. You get 0. Okay, so E, then we would go to Skylar.
0.
Yep. And finally F, Hannah Whipple.
It's undefined.
That is correct. Great job. Everybody, great job. Any questions on any of those? Any of them you want me to work through in more detail? All right, good. All right, now, next, composite functions. Okay, so if f and g are functions, the composite function, the f composed with g, or some students call it the fog, is defined by, and so the fog or the f of g of x can be written as the f of the g of x. Now, I actually prefer this second notation because I think it's less confusing. And so the idea is you take whatever x is, you plug it into the g function first, then whatever that answer is, you plug it into the f. Okay? All right, so now, so you take your x value, you plug it into the g first, then, so whatever function is closest to the x, and then you take that answer and plug it into the f. Okay, so here, if f of x is the square root of x and g of x is x plus 1, okay, the f of the g of x, you take, okay, so the g of x is x plus 1. So if we plug that into the f function, we get the square root of x plus 1. So you take that whole g function and plug it into the f. Now, that's different than the g of the f of x. So here we take the f function and plug it in for x into the g function. So the g function is the input plus 1, so it's just the square root of x plus 1. So it's a little different. All right, then here we have the f of x. So there we take the f function, square root of x, and plug it into the f function again. So we have the square root of the square root of x. So that's x to the 1/2 raised to the 1/2, or x to the 1/4. Or you could write it as the 4th root of x if you wanted to keep the square roots. All right, the g of the g of x. All right, so here we take the g of x, which is x plus 1, and plug it into the g function again, And so we get x plus 1, or x plus 2. Okay? Any questions? All right, so now, again, I've asked you to evaluate these at 0 for practice 2. All right, so Joey, what do you have for A?
It is 1.
It is 1.
Yeah.
That is correct. Good job. Okay, Hannah Zent. How about B?
One.
That is correct. Good job. All right, so I guess we're starting over with Joran for C.
Zero.
Correct. And Rachel for D.
I got 0.
You got it right. All right, any questions? Any of those you want me to work out? Okay. Okay. All right, let's just. All right, let's see here. Okay, let's go back to, so the horizontal and vertical shifts again. So the vertical shifts are when you add a number outside the function, okay? Then that causes the function, the graph, to go up or down. When you add a number inside the function, that causes it to shift to the left or to the right in the opposite direction of what you might think. Okay? So here, and this is why, I was trying to show you at the end of the last section, you can, when you're doing these shifts, you can always check with your calculator. So here you can see like this blue graph is the original parabola. And so if you're kind of exploring what adding or subtracting the numbers here, then you can see the other parabolas, you can see them shifting up or shifting down. And so that's a great example. Okay? All right, so I want you to, for this one, I want you to tell me the parent graph and then describe the shifts. Okay, so, Lana, what's the parent graph here?
Vertical.
Well, there is a vertical shift, but what's the parent graph? Like, is it parabola? Is it squaring graph, square root? What's the main graph to start with?
I don't know.
Okay, so what are the vertical symbols called? The vertical lines.
Absolute value.
Absolute value. So it's the absolute value function is the parent graph. That's the one that's V-shaped.
Okay, will do.
So you start with that. Okay, then you're right, there's a vertical shift and it's gonna go which way?
Say it again.
Right.
Okay, the -2 inside will make it go right 2. What does the -1 on the outside do?
I'm gonna go down 1.
It'll go down 1. Okay? So eventually what I'm going to want you to do is to be able to graph something like that without using your calculator, without doing a T-chart. Is you just say, okay, see this, see the absolute value function goes through the origin, the V shape. But then we're going to move it to the right 2 and down 1. So you move your vertex there and then do the V shape. Now it doesn't have to be perfect, but I do want you to have that point accurately done. So anyway, okay, well listen, that's a good place to stop. So we'll pick it up from there tomorrow. Any questions before we call it? All right, well, you guys have a great day, and we'll see you tomorrow.
You have a great day too.
Thank you.
Thank you.
You bet.